In this example, I want to make the function mults, which I've already started here. Mults is going to take two inputs, m and c. It's going to return some output, and I've written here as a comment, starts with a %, that means it's a comment saying what mults is supposed to do. It's supposed to return a vector of all multiples of m between 0 and c, okay, including the endpoints potentially. So for example, mults 421 goes 0, 4, 8, 12, 16, 20, then it stops. Mults 721, this is demonstrating how if it hits the endpoint exactly, if it hits this 21 exactly, then it includes that number. So 0, 7, 14, 21. And when you get the idea of how to do this, it's actually really easy based off of what we've already learned. The key thing we're going to use is the colon command. So I've already typed this part up and I've saved it. Let me make the output args a little simpler to write. Let me delete that and replace it with w. Lots of times I use v or w when I want to have a vector. So this function, it's supposed to have an output, so that means I have to define this w that I just wrote down somewhere. And what is w supposed to be? Well, this is supposed to remind us a lot of the colon command. So remember how colon worked? We say where we want to start. We say what the step size is supposed to be. In this case, we're going up by m, by multiples of m. Okay, like here I went up by multiples of 4, here I went up by multiples of 7, and the pattern is that it's the first number, it's the m. And where do I want to stop? I want to stop at c, at the second number, or never go past that, possibly stopping before, like in this first example, it stops before. And then I put a semicolon after that. It's good practice to always end these function lines in semicolons, unless you have a really good reason not to. Now I'm going to save it. So one thing to notice is that this is a function that takes two inputs. Now I'm going to go back to the command window, and I'm going to type mults, and let's just test it out with those samples that I gave us. How about mults 421? Yep, looks good. How about the second one? Mults 721? Yep, that looks good. What if I do x equals 13, y equals 100, and then I try to do mults xy? Okay, is this going to work? Is it a problem that here in the function definition I use the letters m and c, and here when I'm evaluating it I'm using other variable names? Well, let's see. Let me try evaluating it. Nope, not a problem at all. So MATLAB knows that x is 13, y is 100. So typing mults xy, okay, that's the exact same as typing in mults 13, 100. What if I had m equals 4, c equals 21 like before, and then what if I do mults xy again? Okay, what's going to happen? Get the exact same thing as when I did it before. So the fact that I changed what are m and what are c out here in the command window, that has absolutely no impact on the m and c that are here. This m just gets defined to be whatever is the first input. So in this case, whatever is this x. And this c, it gets defined to be whatever is the second input, whatever is this y. Okay, so if I type in m here, it's still 4. But if I were to look at what's m inside of the function, it's going to have nothing to do with that 4. If I were to ask what's m inside of this function, okay, so one way I can find that is I can just put an m here with no semicolon, and that's going to print what's m. Let me save it and run it again. So it's kind of weird. Here I have m equals 4. Then I run mults xy. I didn't change what m is. And here I get m equals 13. And again, that's because the m that's inside of the function, it has nothing to do with the m that's defined out here in the command window or the m that's defined here in the workspace.